Welcome back to Breaking Down Storage Tech. Today we're breaking down a dueling hopper set-based unloading array by Kayzm. So, that is a lot of words, but basically it is a system that is used to speed up the sorting of items, because when you regularly sort one thing, it sorts at 1 times hopper speed. Like, if I just get a hopper, let me explain this a little bit better. Basically, what happens is you have a bunch of filters here. Imagine these are a bunch of filters and your items are coming across it and getting filtered. When you have an input of a dispenser, for example, a dispenser, shooting out hoppers into these filters at 1 times hopper speed, your entire system sorts at 1 times hopper speed. Very self-explanatory. But how about you want to make this faster? Well, you could say, oh, well, why don't we just add another dispenser? And then we filter at 2 times hopper speed, because each one of these would have their own inputs. You could have like one right here and one right here. But then the problem is what happens, or if you're just unloading at random, what could happen is both of these could start unloading the same item. And because only these hoppers run at 1 times hopper speed, they will clog up and overfill, and that will cause items to go past even when they're supposed to go into this filter right here. So what this does is it adds a bunch of dispensers, but it uses a bunch of logic to make sure that none of the same item gets sorted at the same time. So that means in this system, for example, this runs at 8x because it has 8 unloaders. You can see 1, 2, 3, 4, 5, 6, 7, 8. So this will unload at 8 times hopper speed, and it will unload 8 different items at the maximum. So you will unload at 8 times hopper speed and nothing will be lost. There's a bit more logic to it than that, but that's pretty much the case. So how does set-based unloading work? So if we imagine this is the sorter right here, and we want to unload all of these boxes right here. Basically, we'll chuck the first box into the system. Once it's in the system, what you do is you take the first item out right here, you put that into the set. This is your example set. And then we send this box right here to go get unloaded. So that box is now being unloaded. Then we take the second box right here and we put that in here. We put that in the system. This gets checked. We take out the first item and then we check, okay, this is not the same item. It's in the set. It's a different set. So we take the box and we put it and to get unsorted. Now, what happens is, what if we get this box? It doesn't really matter what the secondary contents are, or what all the other contents is it, because this system works so that it will only unload the first item. So it'll only work on this redstone dust. So it'll unload all the redstone dust, ignoring the rest of all of these items. So we take the first item, but wait, this stacks with another set base. So what happens is we take this dust back, put it in here, and we cache this for later until this system gets finished. So this box got finished sorting. So we unload everything but one item. This has been sorted in the system. We take this item, we put this back in here, we take this item, and these two go back with the box out into the magical world. And now we've sorted the whole box. And then we can take this box back now, place it. Oh, okay, we can take the first item. Oh, there's no longer a set, or there's now a new space for this redstone dust, and it won't overlap with any other sets. So we can take this box, put it to get sorted, and so on and so forth. Now, the thing about this system right here is that it has a few conditionals. I'm just gonna clear my inventory right here. It has a few conditionals. First, this first item right here, regardless if it's one item or not, it cannot be an unstackable, because that'll just break the whole thing, because that's pretty self-explanatory. Next is we cannot have less than one of the first item, or this is probably not make sense here. We cannot have less than one or less than 2 of the first item, because then we'll take one out to put it in the set, and then this whole thing will just be unloaded a different item. So that doesn't make any sense. So we need at least 2 for the set or this box to be valid and to be sorted. And then the last thing we need to do is check whether once the system's been unloaded, if it has extra items to send to a different or to either send as an empty shulker box or send as a full shulker box to go through the entire system again. So what that actually looks like in practice is this giant thing right here. But this part of the video, or I'm gonna make 3 videos breaking down 3 different parts. This first part is breaking down this bit right here, which is the logic that we just talked about to check whether it has 2 items or an unstackable or 1 item, and check the box. And then this part right here is the actual set and the unloading and loading of the set. And then right here you have the actual dueling hopper unloading array. Okay, so let's get into it. So this system has the input right here, and you can have, or this is the main input, but basically all of it leads down into this chest right here. This chest has 3 ways, and it's the kind of buffer for the system to cycle shulker boxes to check if the item is valid or not. And when I mean valid, I mean has more than 2 items and isn't unstackable. So there's 3 main ways. One is a direct input. This will be from your input to your storage system. There is the recycle input. So if the system filtered out like a box and it had a set unstackable or a single item in it, and it filtered that out, and then you still have items in the box, the system will recycle it and put it back into this buffer. And then also recycling boxes from the dueling hopper array that still have items left in them that aren't the item that they just filtered, so they'll finish those, break the box, and send them into here. Now, what happens when there's items in this right here is that it will lock or power this comparator, which will power this dust, which will lock this hopper right here. This basically locks any input from coming into the system. So that means that the shulker boxes coming from within the system take priority over boxes coming from outside the system. This makes it so that instead of going through 200 boxes for the first item, and then you still have 200 boxes, this makes sure that like a full box gets emptied before another box comes in, if you're reaching like the storage capacity, which I severely doubt will ever happen. Now, what happens then is the items go into this hopper right here. Once the items go into this hopper, they go down into this dispenser right here, or the shulker box. And once the shulker box is in here, it will power this comparator right here, which unpowers this redstone torch by powering this block, which will unpower this activator rail line right here, which will power this observer right here, which will power this observer right here, which will power this repeater right here, powering this activated rail line, which sends a bunch of signals that I'll talk about when they become relevant. Now, at the same time, this comparator powers this block. It also powers this redstone wire right here, which powers these 2 neighboring blocks, which sends signals down this repeater right here and this repeater line right here. What this repeater does is it powers this dispenser as well as locks this hopper. So it powers the dispenser, shoots out the shulker box to be right there, and locks this hopper temporarily. While this is happening, this line will kick in to lock the hopper as well. So this stops any other systems from backing up the dispenser and messing up any cycle for when the next shulker box gets in. Once the shulker box gets placed, there is a few things we check. This section, the comparator taking a readout from here, checks for the fill level of the shulker box once it starts filtering stuff. And then what also happens is the items get filtered down into the first item of a shulker box, because as you know, hoppers pull the first item in a container. So it will pull the first item and start filtering that item by using this system right here that basically blocks all of the other stuff. And what this does is it checks for the other remaining factors, whether it has more than 1 item or if it's an unstackable, by looking at the comparator readout from that hopper and doing a bunch of signal processing. Now, I'm going to break down the comparator readout to check if the hopper or the item is what it is, or is valid. So the item will come down into here, and at this current moment, this bottom hopper right here is locked. So it's stays in this hopper. What will happen is then it will take a readout. Now, a few things happen here. First of all, this comparator is technically reading out a signal strength of 1 from this hopper right here. But what happens is this barrel right here has one unstackable in it, which gives out a signal strength of 1. And because this comparator is in subtract mode, it keeps this signal powered at 0. So this is technically reading out 1, but it's reset to 0. So as soon as one item gets into this slot right here, this will go up to 1 or 2. Now, if the signal strength is 1, for example, if it was just a regular stackable, like a redstone dust got into the system, it would power, but it would not update this redstone wire right here, because this redstone wire has already a signal strength of 1 coming from this comparator that comes from this composter. So it will not send any updates down this line whatsoever. This is how we check for an unstackable. How we check for an unstackable is because when we fill up this slot with an unstackable, it will treat this slot as if it was completely filled. So this would give a signal strength of 3. Take away 1 is 2, which will update this redstone line and send signals down there. But we'll talk about what happens when there's an unstackable in just a second. Now, what happens if this gets a single power is it powers this block right here, which will send a signal to power this dropper right here, which powers it into this hopper right here, and locks this hopper as well. This allows for this comparator right here to unpower and unpower this hopper right here. So this allows items to start filtering down into this hopper and then this hopper right here. So they basically, this is the extent of what can happen. Now this part right here, this hopper is basically to check, okay, there is more than one item. So any item or any filter that has more than one item will get unlocked through this hopper and go into here. How does that work? Well, basically, if there's just one item, which classifies both a unstackable or a single item, what will happen is this comparator will only be on for so long before it undoes power, because the item will get filtered down into this hopper immediately. And so this comparator will be only on for so long, which means this hopper will eventually unlock and let the shears drop back into this dropper right here. This causes the signal from being off to power this redstone dust for not long enough for these repeaters to go to be unpowered. So it keeps this hopper locked right here, and also keeps this piston system extended as well. So that basically prevents any system from, prevents any less than 2 items from getting into the more than 2 item slot. But also, so if there was more than 2 items, this would unpower because the comparator is no longer staying off for long enough for this repeater and this repeater to unpower. Additionally, this repeater also counts as well, now that I think about it. So basically, this will unpower, which will retract both of these pistons. What this does is this piston moves down to here, which will send an update, which will power this redstone right here, which will cause this observer to power, which will cause this observer next to it to powering this dropper right here. Why is this dropper important? Well, what happens when this hopper gets unlocked from this signal being no longer there, the item will travel down into this hopper and go into this dropper right here. So when this gets powered, it will shoot it into the shulker box that's here. How does the shulker box get placed there? Well, it comes down to this other hopper right here, or this repeater right here. This repeater right here powers this dropper and this hopper. So when this unlocks, it allows for the shulker box to make its way down and be placed. Now, I'm going to talk about the shulker box system in just a minute, but ignoring the fact or how the shulker box got here, assume the shulker box got here. As soon as the shulker box got here, this dropper will power and put it into here, and then there's a bunch of processing to break the box and put it through, but we'll talk about that when it comes to the redstone box. Now, at the same time, so that's how an item with 2 or more items gets processed. So it'll get put in this box, break, and go down the system, and will go up all the water stream and go into the set-based filtering. Now, what about the other two scenarios? When there's one item and when there's an unstackable. Well, when there's one item, this line doesn't power whatsoever, but it's still this signal still powers. But the only difference is that all of these repeaters right here don't unlock. So that means that the item will get stuck in this hopper long enough to power to this dropper right here. And from this dropper right here, this dropper will get powered by the signal coming to this redstone dust. What will happen is this redstone the comparator will unpower because it does get pushed up, or the item does get pushed up because the signal is there for a little while, but just not as long, which will cause this note block to unpower, causing signals to these two observers to fire right here. So it'll power this observer and this observer, which will power the dropper and the hopper underneath it. So this prevents the power going to this hopper right here, prevents any items from going from this dropper right here to be filtering down, and it also powers this dropper right here, shooting it out into this water stream, which comes down here and goes down through this line right here. And this goes through these sorted items right here. This is where all the output to the system would be. This right here is the theoretical output to the system, where you have your chest holes or bulk holes or whatever it may be. And it's the same output as the dueling hopper array right here. Now, what also happened, or what's the other possibility, is there's an unstackable. What happens when there's an unstackable is this line gets updated. Now, the system works previously as before. It's only one item, so the system works as before, and it makes its way down into this dropper right here. The only difference is this line got fired, and because the unstackable caused a signal strength of 3, which updated this line right here, which sent signals to all of these systems right here. So this causes an observer line to power all the way down, and it causes power to go to this note block right here, which keeps this hopper locked for slightly longer. Now this is important because then it makes its way all the way down into this hopper right here that we were just talking about, slightly after these two observers fired, so it stays, or it makes its way down all the way to this dropper right here. And then this dropper is then powered by the redstone signal coming from these two repeaters, which came all the way down this observer line and powered into here. And it makes down here, and then this is your unstackable output. Now, shulker boxes. Shulker boxes are a little bit different, but basically the fill level of a shulker box. So you'll place it right here, and if the shulker box has any fill whatsoever, if it's not just a completely empty box, then it will give a comparator output. This comparator output will power this comparator and will lock this repeater right here. This causes an observer update to this observer right here, which I'm not 100% sure what it does. I do believe it powers this dropper right here, but I'm not entirely sure. But the important thing is it locks this repeater right here, which sends a line to this observer line going all the way across through here. It goes down this line right here, and it powers this dropper right here to shoot it out, which will cycle the box if in reality it is if it's only one item. So basically what happens to the box is when it gets broken from this piston firing, which occurs from a signal, from this signal right here. No, where does this get its power from? Yes, no, sorry. So it does get its power from, so I just forgot, but basically this this rail line right here that we talked about at the very beginning of the breakdown, it powers this line right here, and this causes a observer to power right here, which powers this block, which powers this piston, breaking the piston, or breaking the shulker box, and it pushes it so it goes right down into this hopper right here, which will push it into this dropper right here. Now, if there are more than 2 items, this repeater will be unlocked so that the shulker box will filter all the way down into this dispenser, which will then be powered by the signal coming from this observer piston getup right here. Basically, when this observer moves down, when the system detects that there is more than 2 items coming from this repeater, it will power and go down all this rail line, and it will power this dispenser right here to shoot its water into the stair right here, which will cause a update to this observer right here, which will power this block, powering this piston to break it. But just before that, the same signal that came to check that if it's more than 2 blocks, it will unlock this hopper, and when it repowers, it will power this dispenser right here, shooting it out right here, so it can pick up the block shot out from the item shot out from the dropper and then be broken. Now, what happens when it's also broken is there's this observer reading the observer signal, detecting the water placement, that'll fire all the way through here and send a signal to power this block, note block to power this observer, powering this dispenser right here, this dropper right here, to shoot out the shulker box up into the system to get sorted. Now, what happens if there isn't more than 2 items? Well, this hopper right here never gets unlocked, so it gets put into this dropper right here. Now, this is where the importance of the system comes in. Basically, if the first item gets filtered out and there is no more items in the system, it is an empty box. Like, for example, this case right here, if there's no more, it will have no more, or it will just be a completely empty box. So this comparator won't power this signal, so it won't do this observer line, so it won't power this dropper right here. So the item will be shot into this dropper, and because this hopper is unlocked, it will be pulled out because it just stays in the dropper, and it will make its way down into this dropper right here, which will then take a comparator output, which will power this block, unpowering this rail or redstone line, which will unpower this rail, which will send a signal to this observer right here, which will power the block, keeping the redstone torch unlit, which will power this observer, which will power this observer, which powers the dropper to shoot out the item or the shulker box, the empty shulker box, as well as power this block up here, which causes the system to fire a few times. For example, if I were to get an empty box right here, oh, that didn't work. Here we go. If I take this right here and put it into the system, you'll see it'll fire a few times. This is mainly done under the logic that if you have a bunch of boxes here, it would be more lag efficient to just fire the system a bunch of times to clear out any buffer, rather than to deal with like the whole get in a box, run the system, and then shoot out the box and then check again, because then this comparator has to keep reading out and the signal, and then there's quite a bit of delay which could cause a buildup, while instead this system just fires it a bunch of times to clear out any buildup. Now, the last case scenario is if there is items in the box. Well, if there is items in the box, this observer line or the comparator will have powered or stay powered, which will keep this repeater powered, which will power this observer line, which will shoot power this dropper to shoot the item or the shulker box with items still in it to go back into this original beginning of the system. Now, that is quite a lot that happens in this very compact system, but yeah, it's quite actually useful, because now that we know, or basically we can filter all other items at 8 times hopper speed, or 16 depending on the version that you use, but this is 8 times hopper speed. But it also conveniently filters out for you all unstackables, so all unstackables can go into their respective unstackable sorter, and you don't have to deal with putting them through your storage system, alongside filtering out shulker boxes or empty shulker boxes, so you don't have to deal with like making sure it's a shulker box in your unstackable sorter, as well as filtering or not having to double check that they're empty because you're guaranteed that they're empty. So this basically means that this system does technically three sort or a lot of convenient sorting for you at once, so that way you don't have to have a bunch of redundant sorting later on. So overall, a really great compact system and very smart system. It's very logical and I quite like it. So yeah, thank you for watching.